This is number what, 2? All right. It's basically 2, 3, and 4, but we'll take a look. It says point K is the centroid. That point K is right here in the middle. How do we find the centroid? We go from the vertex where? To the midpoint of the opposite side. All right? And we went from this vertex to this midpoint, this vertex to this midpoint. Everybody see that? All right, that's the centroid. And it says line segment DK is 12. No, 16. So, right, they do say this is 12. And they say DK is 16. So from here to here is 16. I guess I should put some letters in here, shouldn't I? It's D, G, C, H, F, and J. All right, so this is all the information they give us. What's true about the centroid, though? Go back to 337, page 337. Now, how do you find the centroid? You find the median, right? But what's true about that centroid? This is the one where the centroid is what to the whole thing? It's 2/3, right? The whole from here to here is 2/3 of the whole thing. So that means this little bit is how much? 1/3, and this bit right here is 2/3. Okay, so what are they asking for on number 2? They're asking to find KH. Okay, and KH would be right here. Just call it X. Everybody watch this? This one's not hard at all. Look, you got to realize, though, the only thing that's hard about it is realizing that, oh, this is 2/3 of the whole thing. Or it's how much of the shorter part? No, of the short part. This thing right here, this longer one, is double. It's double the shorter one. It's not half the shorter one. Okay, it's double the shorter one. From the vertex to the centroid is the longest part. Okay, from the centroid to the midpoint is the shorter part. You got it? So sometimes when they draw it, it's hard to see which one's longer, which one's shorter, just the way they draw it, because it might not be drawn to scale. But this is twice as big as this. So what's X equal to then? If this is twice as big as this, that means this is half of this, right? So this would just be what? 8, okay? What would this be? What would GK be equal to? 6, right, because it's the same thing, right? This is half of the longer part. From the vertex to the centroid is the longest part. From the centroid to the midpoint is the shorter part. You got it? Okay, so this part is shorter than this, and it's half of that, so that would be 6. All right? What about... Oh, they tell you this is 9 also. Okay. What about CD? What if they ask for CD? From here all the way to here. How'd you get 18? They're both equal to each other. That's right. This segment from here to here, that's not double or half, is it? It's, or a third or whatever it is. Okay, so from here to here would be 18 because they told you this is 9. Since this is a median, this will be 9 as well. So that whole thing is 18. Make sense? All right. So that's centroid. Centroid. I believe on the test I have a centroid problem on there. Okay, so make sure you know the centroid. How do you get it? Find the medians, which is the midpoint. You go from the vertex to the midpoint. And what's true about the distance of that median? Well, from here to here is half of from here to here, right? Or you could say the longer one is twice as big as the shorter one. Okay. Okay, what if they told you this? Yes. What if they told you the whole thing? What if they said that this was 18? All right. Hello. Yeah. What if they told you this was 18? What would the shorter one be? Divided by 3. I'll just say it again. Do you mind? All right. So anyway, if the whole thing is 18, what do? You take a third of it, right? If you take 18 divided by 3, it's 6. You take that 6, you double it, and you get the longer one. And there you go. That's 6 and 12 is 18, right? All right. Or you could have done this. I didn't even think of this. You could double it to get that, or you could just do what? Take 6. No. Yeah, away from 18. 18 minus 6, right? Okay. Either way, it still works, doesn't it? Okay. All right, good. All right, this picture doesn't look exactly perfect, but it's close enough. It's number 6 right there. Thanks for playing along. Okay. Let's see what we got here. Let's mark this. This is R and S and Q and T. This little segment is 8, so is this one. And this is 43 degrees right in there. Wow, they tell you tons of stuff, don't they? And they ask for angle TQR. TQR. Let's find TQR. That would be this one right here. Oh my goodness. How easy is this? Look, here's the deal. All right, if you have a point right here and it's equidistant from the sides, that means it lies on the angle bisector. Okay? So look, I've got an angle here and an angle here. That means that this and this are equal to each other. And I got this equal to each other, right? So what's true about those triangles? They're what to each other? We don't say triangles are equal. What do we say? They're congruent to each other. We say the triangles are congruent to each other because of angle, angle, side. You see it? These triangles are congruent. What's true about these two things right here? They're going to be the same. Okay, so if that's 43, what's this? It's 43. Easy as that. Okay, or you could have gone. Yeah, that's all there is to it. Okay, didn't have to do any math at all. Well, my goodness, that was almost a waste of time, wasn't it? Do that. Well, I mean, it wasn't hard to do, but the thing is, listen, it's not hard to do because you just say, oh, they're equal to each other. But the fact that they're equal to each other, that's what you have to know, right? That's the geometry. The geometry part's not a lot of work, is it? Most of the work that we do is the algebra, right? When you have a lot of work to do, it's usually the algebra. The geometry is not hard. The geometry is just knowing what's equal to what. Does this equal this, or does it add up to be equal to 180? Does it add up to be 90? All that kind of stuff. So the geometry is just a matter of knowing what's equal to what and the relationships between those sides and angles. So just because you looked at it and said they were equal, it was easy enough to do, but you had to know that they were equal to each other. All right, so that was number 6. Let's take a look at number 7. And they say solve for xz. Well, it's the same kind of deal. Let's just try to do this real quick here. It goes here, it goes out like this, and looks something like this. Not exactly. I know it's a little bit off, but I'm just hurrying. And they say that this is a right angle and this is a right angle. Now look, this time they tell you that these two angles are equal to each other. And they tell you that this is 3x plus 5, and they tell you that this is 5x minus 7. Alright, same kind of deal, isn't it? Look, I've got two angles and a side, right? Congruent triangles. What's true about this side and this side right here? They're equal to each other. So it's not a matter of just looking at it and saying, no, the answer is whatever, 43 degrees like the other one was. Okay, on this one you have to do a little bit of work, but you just set these equal to each other. That's all you do. So 5x minus 7 equals 3x plus 5. Subtract 3x from both sides, you get what? 2x. Okay, add a 7 to both sides, you get 12. Divide both sides by 2, you get 6. Okay, now the question says find xz. Now I didn't mark anything, but this is x and this is z. So if they say find xz, what do? Do you circle this and say x equals 6 is your answer? You got to plug it in, okay? So you put it in right there. So it's 3 times 6 plus 5. That's 18 plus 5 is 23. So that side right there, xz, is 23. Make sure you realize that, because there are times where you have to solve for x, then you got to plug it back in. My goodness, on my on that other, what's the other class called? The honors geometry class. I gave this quiz. I mean, even my top students, even one girl in my honors class hasn't missed a question all year on any, it's a girl, on any quiz or any test. She has not missed one question the entire year. And you know what she forgot to do? She forgot to take this and plug it in, because she got x is equal to 6, and she forgot to put it into this. Listen. She forgot to take this and put it in to get that answer. All right. So even somebody that never ever misses a question, has a tendency to forget to do that. So my point is, remember, look to see what you're solving for. Okay, you're solving for xz. Make sure you put that back in. Find what xz is equal to. Everybody got that? Okay. So look at 9. It says you got two sides of a triangle. One measures 3.1 feet and the other one measures 4.6. Now this is multiple choice on this practice test, but on the real test you won't have multiple choice, okay? So you won't have anything that looks, just like this, but the whole idea of what we're trying to learn, you'll have a problem like that. So it says, what's the least possible whole number measure for the third side? So look what they give you. They give you 1.6. Part B, they give you 2. C, they give you 7.5. And D, they give you 8. Now, read it again. It says, which is the least possible whole number measure? So right off the bat, what can I get out of there? Okay? Yeah, this is supposed to be a point. Right. I know that that's not going to work and that's not going to work. Why not? Because they're not what? They're not whole numbers. So it's either between this and this, okay? So, and it says the least, okay? So you could just say, okay, that's it right there. But let's just try them. Could I have a side that's 8? Could I have a triangle that has those lengths right there? Remember what the rule is? You take the two smaller ones and you do what? You add them up. So what would I get for that? I get 7.7, right? So what is the... If I take the two smaller ones and add them up, what does it have to be? It has to be what? It has to be greater than 8. Is 7.7 greater than 8? No, it's not. Okay, so 8 can't be one of our answers. So really, 2's got to be our answer, right? But what if I asked you, without multiple choice, what can the third side be? Can it be a 2? Yeah, because you take the two smaller ones. Now which ones are the two smaller ones? 2 and 3.1. 2 and 3.1 is what? 5.1. Is 5.1 greater than the third side? 4.6? Yes, it is, okay? Because it's not a whole number. Because the problem says whole numbers. Okay, 1.6 is not a whole number. 7.5 is not a whole number. Everybody understand that? Okay, so it's either between 2 or 8, so you try one, right? This one didn't work, so this one must be the one that works. Easy enough. You won't see one like that on the test, though. But you will see something. I could do this. I could say, do these three sides form a triangle? Yes. Right? And then you have to tell me yes or no. We have to give you a... I don't think I ask for a reason. So really it's 50-50, but what did we talk about? Yeah, it's a lot better to be 100% than 50%. Wouldn't you agree? All right, what was that, 9? Let's take a look at 10. I got to draw the thing out. Okay, so we're finding the in-center. In order to find the in-center, you take the angle and you find the angle bisector. So look what I'm doing. I'm trying to bisect this angle right here. All right. I'm not really looking to find out where I end up here. I'm just looking at this angle. I'm trying to split it in half. So would I go like this? No. Would I go like this? No. I'd go around here somewhere, wouldn't I? Like that. Okay, good enough. I don't want to take forever on this. We'll just kind of eyeball it. And if I split it, it would go about right there. And if I split this, now they should all intersect, right? Now what I'm going to do, this is what they do in the book. They don't take it to the other side. They just take it to that actual point. Everybody see that? So they just take it to that point. Now what am I doing to find the in-center? I'm bisecting these angles. So those two angles are equal. These two are equal. And these two down here are equal. Okay? To find this point right there. That's the in-center. But, tell you what, let's do this in a different color now. Let's go red. What does it say about that in-center? Is it equal? Is it 2/3? Is this the one where it's like 2/3 or anything like that? No, it's not. What does it do? It's equidistant, right, from the sides, which means it hits. Now these may not look like they're exactly equal because we kind of eyeballed it just a little bit. But if you did it perfectly, all three of these red lines should be what to each other? Should be equal to each other, okay? So all three of these red ones should be equal to each other. This, this, and this. On the what? On the in-center. Everybody got it? How do you find the in-center? You bisect the angles. At that in-center, what is it? It's equidistant from the three sides of the triangle. Got it? Let's see now what they give you. They give you, this is 24. They say this one right here is 25. This is 28 degrees. This is 30 degrees down here. They say this is 11, this red one. Okay. Oh, yeah, that's right. It's probably this one right here, isn't it? Sometimes the way they mark them, it's hard to tell which one's which. But you're right. It would be that one right there. All right. And this is D and F and G. Middle's H. Okay. Let's see what they're asking for. They ask you, let's just do them all, okay? So number 10, they ask you for DH. DH from here to here. What do you think? Alright, these two triangles right here are congruent because of angle, side, which means if this is 24, this is 24, and look what I've got. I just took this triangle and straightened it up a little bit. Everybody see that? So look, I got 24, I got 25, I got X. What do we use? What math do we use to figure out what that missing side is on a right triangle? It is a theorem. What kind of theorem? Pythagorean theorem, right, which is a squared plus b squared equals c squared. Okay? I know. I can go over 15, thanks. You're a minute late, but that's okay. So watch. What do? We go x squared plus 24 squared equals 25 squared. Now, if you do the math, I'm not going to take any more time on this, but if you do the math, you can do this on a calculator, right? 25 squared is a big number. 24 squared is a big number. You subtract them. Then you take the square root, and you get x equals 7. All right? Trust me, you can do that on your own. I doubt I'll have one like this on the test, but I'm just showing you how to do this problem. So that means x is 7, which means dh is what? Is 7. There you go. You probably didn't expect to use Pythagorean theorem on this, did you? No. But there you go. You've learned it, right? You learned it in Algebra 1, didn't you? Pythagorean theorem? Yeah. You'll learn it later on this year, too, in geometry. But you already know it now. So there you go. So that thing right there is 7. All right, so that was a little tougher than you probably anticipated. What about BD? Let's find BD. Where's B? BD from here to here. Pythagorean theorem again. Look. No, because look, this is 11 and this is 7, right? That's your hypotenuse. So let's call this y, right? So from here to here, that's what we're trying to find. So I go y squared. You'll need a calculator on this one. Y squared plus 7 squared equals 11 squared. All right. Somebody have a calculator out? Somebody punch some numbers in for me. So it's going to be 11 squared minus 7 squared. So that's 121 minus 49. What's 121 minus 49? Somebody real quick. 72. Okay. Hit the square root button then. Hit the square root of 72 and see what you get. Around 8.5. Did you hit square root of 72? Do you get, if you round it, do you get 8.5? Anyway, that's yep, that's what you get. So BD, yeah, BD from here to here is 8.5. There you go. So let's do this. Let's find HAC, angle HAC. Angle HAC. Where's H? Right here. A and C. So this one right here. This is what we're trying to find right there. Well, watch. This angle's 30, isn't it? Yeah. Right here. And this is 90. What's this angle right here going to be? Right where my pen is. What's that going to be? 60. That's right. That's going to be 60. What about this one? This is 30. That's 90. What's this going to be? That's going to be 60, right? How do I find this angle right here? Actually, what you could... Now, let's do it this way. This is not 60. What do we got? 28 minus, or 90 minus 28. Do it. What's 90 minus 28? 62, right? Yeah. That's 62. What's this one going to be? That's going to be 62 right there, okay? So look, what are we trying to find? Let's find that whole big angle right there. Okay, ready, there? Type them in. 60 plus 60, that's 120. And then plus 62, plus 62. Minus, what do you got? 240 what? 244? Okay. Now look. It forms a whole circle, right? So take what? Not 180, but 360 minus 244. And what do you get? You get a 6, you get a 1, you get a 1. So 116? So what's half of 1? And look, these two are equal to each other. They add up to 116. What's half of 116? What is it? 58? All right. There you go. And that's not the right answer. What did I do wrong? Let me check it. I'm sorry. That's not our final answer, though. It's not 58. What are we trying to do? We're trying to find this angle right here, aren't we? Okay, so what do we do now? Go 90 minus 58. What's 90 minus 58? It's 32, and that's our answer. Yeah, you probably could. I don't know. That's just the only way I saw it. What'd you do, Joel? Come on. That's a pretty good way to do it. There might be a better way. I just don't see it off the top of my head right now. But yeah, we'll just leave it like that. Okay. This will be on YouTube, yes.
You changed a while ago, Rayvon.
What's that?
You're not funny.
Not yet. We're not done. What's everybody packing up for? Watch. Angle DHG. Find that. D. Is this H? This is so sloppy now. G. All right. So I want to find this whole thing. Oh, that's easy now. Look. I want to find this angle right here. So what's that? 120. Right. From here all the way to here is 120 because it's 60 and 60. So DHG is 120. All right. So that was the easiest one. Number 13 was the easiest out of the three. So that's a little bit tougher than what you've been having, but there you go. 14. Oh. No, you're going to hang on to them until tomorrow. Turn them in when you take the test, okay, before you take the test. Don't leave them in your locker. Don't put them in your book and leave your book in your locker, okay? You're turning it in tomorrow before you take the test, so be ready for it.